welcome to another episode of EPARTRADE Live. This is Valves for Race Engine Applications, What You Need to Know. And it's presented by Willy and Martin Tagliavini from SuperTech Performance and Race Engine Specialist Tom Fujita of Portflow Designs. I'm your host, John Kilroy. I'm Chief of Content and Audience Development for EPARTRADE. This is the fourth one we've done of EPARTRADE Live, and I'm enjoying the hell out of them. This is great people and great insight into the technical side of racing and the business side of racing as well. For EPARTRADE, we just rolled out a big announcement yesterday. So we're organizing an online race industry week for this year. The in-person trade shows are either canceled or they're just in jeopardy due to the pandemic, which is a damn shame. So November 30th through December 4th, we're gonna have online race industry week. We're gonna get all the manufacturers to introduce their 2021 products on EPARTRADE, and the shoppers and buyers in the industry can just go there. And so a really neat thing about EPARTRADE is once you, a supplier uploads a new product, it goes right to the homepage of EPARTRADE. So that week, you'll basically be able to tune in and just see a parade of everything that's new for 2021 on EPARTRADE. And we want everybody to be all in one place at one time. That's the magic of trade shows. We just can't do one perhaps in person this year. The PRI show hasn't canceled. SEMA show has canceled. We'll just kind of see what happens. But because of the pandemic, it's not good for anybody. So we'll also provide a week of content such as EPARTRADE live webinars and other kinds of online content. So put us in your schedule, November 30th through December 4th. Spread the news all together now. A quick housekeeping note. We're going to try to mute the attendees, and typically they don't have video on as well. It's just kind of keep this thing flowing without disruptions. And then, this is very important, we want to answer your questions. So we really want your questions to come up in this webinar. At the bottom of the Zoom screen, there's a chat option. And you just click on the chat option, and you can type in your question for Martin or Willy or Tom. So just start now, get your questions together now, and we'll get them as part of the webinar. Alrighty. And then our speakers, SuperTech Performance is a great company. Fuses technology with passionate people, really passionate people. And they've been doing it for 30 years, creating the highest performance valves and valve train components in the industry. SuperTech provides the racing market with superior valves and valve train components for virtually every type of racing, drag racing, rally, road racing. And they have a perfect solution for you. And if not, they'll make a custom valve for you, solve your problem. Willy is the founder, owner, managing director of SuperTech. He found his passion for racing at a very young age, growing up in Argentina, a vehicle development engineer for Ford. Martin is Willy's son, and he's chief marketing officer for SuperTech Performance. Tom, again, with Portflow Designs, basically a whole lifetime in working on valves. So he's a valve job technician from 86 to 90. And then right away went to work for Nissan Performance Technology, Cosworth Engineering, Honda Performance Development. And then he's been with Portflow Design since 97. He's kind of the guy a race engine builder turns to get more out of a cylinder head. So he specializes in 4-valve cylinder heads, everything from mopeds to Ferraris. And then he has a new and Contour BV machine, and we'll talk about that later. So anyways, thank you all for being here. We'll get started. And I'll ask this question of Willy. We kind of talked about it yesterday. We talked about what questions to ask and what questions we should address. And kind of the first one is very basic, is why does somebody turn to a specialty manufacturer like yourselves for specialized valves versus just stock valves? So Willy, why don't you take that and go ahead and speak up, Willy.
Right, yeah. I mean, basically what you are looking in a race engine is to increase power. Valves, can, help to achieve that increase in power by increasing the flow rate, by, making the valves lightweighter, so in order to take, chance of, more aggressive camshaft, and be able to rev, at higher RPMs. Also, to be able to cope with the higher temperatures that, race engine have, normally aspirated or, even more now, turbocharged cars, you have to cope more and more with higher temperatures. You achieve the higher flow rates with, design, very detailed design, testing, flow testing. Tom knows a lot about that. And higher RPMs, you achieve it, by redesigning the valves, making it a little bit lighter. You have a lot of limitations with the stainless steel valves or steel valves, in terms of, well, you can remove some weight of them, but you are very limited, in what you can do because of the shape of the valve. Or you can change materials, do them in titanium that are about, 40–43% lighter. Titanium is, good for that, lightweight valves, but not very good in other, in other specifications. And then for, to cope with, high temperatures, there are several alloys that are, available to manufacture, from stainless steel, Inconel, or, then you can go up to Inconel or mnemonic. It's basically the same thing. You can add sodium filled valves. In lightweight valves, you can also add, I forgot, you can make the valves hollow to make them, without sodium, to make it lighter in, when we are talking about steel. So then we can enter, in more into the details of everything, how you design, a valve to make it flow better by, decreasing the diameter on the valve with the analyzing the radiuses or the back angle of the valve, the back cut angle also have a lot of influence, in the flow rate of the valve. That has to be analyzed, Initially, sometimes, you can do it, with a CFD software, and then Tom takes over and do the, real testings in terms of flow rates. Making the valves lighter, well, that involves also, trying to make, T-shaped valves, that, and neck down of the valve to improve, or remove some material. Or make them hollow, let me see what we have here. Hollow valves like this one, where you can remove, part of the material inside the valve, and then you make it lighter. And to cope with temperature, we use, well, stainless steel has a better resistance to fatigue, at higher temperatures. There are also several grades of stainless steel. We mostly use two alloys, EV8 on the intakes, and EV16 on the exhaust. This is because, exhaust usually have to cope with, maybe 2–3 times the temperature of, the intake valves. If you go turbo, then you resort to Inconel or mnemonic alloys, which has, much more resistance to fatigue at higher temperatures. And then if that is not enough, then you can resort to sodium filled valves, that has been used in racing applications for many, many years. And it's, getting more and more popular because of the increase in power due to, smaller engines and higher turbo boost engines. So, basically, that is, what's going on, in valves.
Okay. When I go through engine parts, a lot of them just seem to be bulletproof, and you can almost hit them with a hammer, with piston or crankshaft or connecting rod. I always thought the valve looked like the most fragile thing in an engine. And how do you, in the manufacturing process, what are some of your steps in manufacturing where you get that reliability factor at the valve. You get to last so long. It's got to be hard to do.
Well, you start with the forging. And forging, for that purpose, in our case, we have a forging for every, almost every part number. Because to use, sometimes you can use a generic forging, from there you can, machine a lot of parts. But we choose, to have a forging for almost every part number. That will increase reliability because you don't have to machine too much, the angles, the neck down. You machine as little as possible, to end up with a shape. And then we do, this heat treatment for, removing stress to the material. Then we do the machining. We do another, heat treatment for, distressing the material. Then we do in our case, black nitriding of the valve. And we do another grinding at the end of the valve to ensure, the concentricity of the valve. Concentricity is very important, because it improves the fatigue life of the spring, of the valve. The same thing with the black nitride. That's why we insist a little bit with the black nitride, because you can Google it, nitriding, heat treatment improves the fatigue life of the material. In our case, this is a more sophisticated nitride. Actually, it is called QPQ, the heat treatment. You can also Google it, find all the details about, that kind of heat treatment. But, that's the way, and of course, there is a lot of, quality control in every step of the machining, In our manufacturing facility, there is a, very sophisticated quality control. Because in our facility, we manufacture not only race, valves for our application. We manufacture valves, for racing application, race engine valves for some of the big manufacturers. We manufacture valves for aircraft engines. Wow. So, yeah, so you can imagine the kind of, quality certification you have to have, even we have audits from the FAA, to make sure, everything is, under control, making sure of the reliability of the valve. So, we are sure about that. It's very, very well set up.
Yeah, very good. And then I'll ask Tom a question. And Tom, what do you look for in valves for your performance engines and your cylinder heads that you work on?
I only buy the valves from Willy, so. Well, they gotta have a back cut. There's different. I see there's like a question about flow. So, we found like sometimes if the port's too big, sometimes that area where Willy's talking about, that back area, if it has more, it could actually increase the flow. So when you do valve testing, the same size valve, not just going bigger. Most people just think just put a bigger valve in it, it's going to flow more. But if you don't cut the seat properly, it's not going to work. So, like I said, I only buy the valves from Willy, so, but he makes, they're really good to begin with because we've tested them back to back against other manufacturers. So, and you can see the difference. You can see the back cut. You can see the undercut on the stem where he's taking the weight out. And then there like he's talking about the sodium filled stuff too. That's a really old trick, I guess.
Yeah.
And Mercedes did it, but back then the stem size was like 10 millimeters, 9 millimeters. Porsche's 9 millimeters air cooled. But all the stuff we see now is it's really tiny. So I'm kind of amazed how you get the sodium in that little tiny valve.
Yeah.
But that's got to help too, though, as far as pulling heat from the motor or helping it dissipate.
Yeah.
And then you need, then there's other things too, like the valve seat material that we're using, that Mold Star 90. So there's a lot to it.
No, I bet.
It requires a lot of testing and doing. It's time, and unfortunately, that's one of my things I don't have a lot of. So if you're trying to run a business, you don't have a lot of time to do like development. So that's where I'm kind of limited.
Yeah. Let me ask a question. Tom, let's go ahead and ask a question now from the audience. And I'll give this one to Willy. How has the introduction of direct injection influenced valve and cylinder head port design? And Willy, why don't you take that one, and we'll get back to Tom for his answer.
Yeah, well, right now, it's a combination. I mean, valve-wise, I mean, yeah, there is a problem because, the valve, with direct injection, they don't get washed out, during the intake, charge. So now they are using specialized oils, to avoid this kind of issue. It's not related to the valve, but the whole, engine operating system, and now there are specialized oils to avoid that kind of thing. But direct injection has come also along with the turbocharging, and so all of that, forced us, to make, sodium field valves. Many engines, from the factory come with sodium field valves, which is a very interesting valve, a very interesting, manufacturing process. Like Tom said, how you do, to insert, because there are valves with 5mm stem sodium field, So it's interesting, the manufacturing process. You have to be done in a very well-controlled environment because humidity can make disasters, with the sodium. Yeah. It's a little bit explosive, so you have to be able to handle it, in a very well, controlled environment. But it's very interesting, and the technology. I heard somebody asking me not long ago, that the sodium field valves are not really good for racing because the sodium would evaporate, at 1600, degrees Fahrenheit. But that is not true. I mean, it's true that in ambient temperatures, the sodium will evaporate. But when you insert, sodium inside a closed chamber, you know what happens. You increase the temperature. Along with the temperature, there is an expansion and there is an increase in pressure. Like everybody knows, even in your car cooling system, you pressurize the system in order to increase the evaporating point of the fluid. Well, the same thing happens here. So actually sodium will never evaporate inside a sodium field valve. I mean, the mnemonic or inconel will melt, because we have calculated that, will melt before the sodium evaporates inside a sodium field valve. Okay. So that rumor doesn't cut it.
All right, we took care of that rumor. And then Tom, I'll throw the question over to you. How has the introduction of direct injection influenced valve and cylinder head port design? Tom, do you have anything you want to add?
Well, the way they make them, it's performance-wise, they're horrible. There's more than a 90-degree edge. It's more like I guess 120 degree. It comes to like a point where it shouldn't, but it's made like that to increase the swirl so it's more efficient. But performance-wise, I've been doing some of these EcoBoost heads, and it's by modifying that area where we normally modify it. It's a huge gain. So they've been selling pretty good lately. It's what's been keeping me busy. So we kind of switched from Japanese engines to domestics. But it's it's 4-valve technology. So, but like he said, is issues with that as far as the all the stuff that gets built up on top of the valve. Even I've seen it on Ferrari, the 458, their direct port, and you take it apart. And on the Ferraris, they usually don't have that much mileage, so they're more like they're sticky. It has like a film on it. But I did take apart this Volkswagen Mark IV. Not sure exactly what comes out of a Jetta, I guess, but it's a direct port turbo. And the valve looked like a lollipop. It was just caked full of carbon and gook, and then talking to more and more people, they have that, I guess, like BMWs are like that. They have some service where they walnut blast the ports on your car. That's some kind of valve cleaning service at the dealership. So I kind of wouldn't want to know what it costs, but probably a lot. Because
I ask another question, Tom, and this question is for you specifically. Do you specify valves, or more specifically valve shape, based on flow? For example, on an exhaust valve with a slightly convex head versus a concave head.
Convex head or concave? On the exhaust side, I think it's more or less the shape of the seat that's gonna help gain your airflow. And we found that by putting that radius beneath the 45 is what works the best, and having a lot of it. So it's one of those old things where they say less is more, and it's really true on the exhaust side. Usually depends on which head it is, but because everybody has, every manufacturer, they're all different. So some are really good, some are like the Hondas are really good. So there's not much to do to make them a little bit better. And then you have that Ford EcoBoost that flows horrible. That it takes quite a bit of material out of the pocket area, but just reshaping that. We've seen 60 CFM gain at like 400 lift, and I've never seen that on an engine.
Yeah.
From a stock to just mildly modified, and just because it's so bad to begin with, so it's kind of one of those things where when you walk away, you're like, yeah, I got some good gain out of that.
Yeah.
But it was really bad to begin with, so that's probably what it should have been flowing to be to begin with. But they want to make it efficient, so that's what it is. So I kind of don't understand that convex and concave. If you're talking about a dish being in the valve, I would prefer to see a dish because it makes it lighter. But I don't really understand where he's talking about convex and concave. I mean, what area of the valve is that in the tulip part, or because then you have different shapes. I guess you'd have a tulip or like a nail head. And I think the tulip works better. I guess it'd be heavier, but it comes down to that same thing. When the port's too big and you add material right there, it actually helps.
Okay. All right, I'll ask a question now for Willy. And again, I'm getting these questions from the chat option at the bottom of the Zoom screen. Just click on that and write in your questions, and we'll pose them to the speakers. So Willy, I'll just read off the question. Any experience with these NASCAR engines where water temperatures reach 300 degrees at times with the valve's extreme temps? Any comment about that, Willie?
Well, to be honest, right now we are not suppliers to NASCAR, but, NASCAR use, mostly titanium valves made by a manufacturer in California, mostly. And, they have to deal, I mean, NASCAR specifically, but, it's like IRL or Indy Racing also, they are, Indy, for example, you use turbocharged engines, and they deal with titanium valves, and they have to use sodium-filled titanium valves on the exhaust side to be able to, achieve what they want, reliability, at, pretty high temperatures, in racing, with a turbocharged engine. So that's the thing. No, it's the intake side is not a big deal because, like I said, they don't work at, even in turbo applications, they don't work at very high temperature. The problem is the exhaust, So,
Okay, I have another question, Willie. While recommended maximum cylinder head temperatures still remain somewhere around 425 degrees, I would imagine that with new technology, the valves remain more intact when the heads exceed 500 degrees. They remain intact more than valve materials of the past, therefore reducing the need to replace them after an extreme heat cycle. Do you find that to be true? Are the valves doing a lot better these days in extreme heat?
well, with the materials and the new technology about sodium-filled valves, yes, the longevity of the valves is certainly much longer. I mean, we have seen, why we started doing, even before all this, all this now OEM cars that came with, sodium-filled valves. Before that, in racing with turbocharged engine, let's say global rallycross, for example, they use, 4-cylinder engines, 600 horsepower engines. Some of them using 2-liter, they have restrictor. The temperature goes very high, and people are coming to us and say, hey, every 2-3 races, the valves warp. This is because using even using Inconel, you get too much temperature, and after a while, even with that kind of materials, the valve tends to warp, start leaking, and eventually will burn. So we solve these issues, with sodium-filled valves. Of course, this is part of, the solution also. You have to take care of, seat material, guide materials, and cooling of the engine. But, that's how we started, making, valves, in sodium-filled exhaust valves. Of course, this has been used for many, in racing, we are, still doing, YB valves that, were originally made in sodium field. We are still making those, sodium field, so they have been, in the market for many, many years.
Okay. I'd like to ask the question of Tom. Tom, you mentioned you have a Neuen Contour BB machine, and I love Neuen equipment. I think you could do magic with it, especially with someone like you at the wheel. Tell us about that. We probably have professional race engine builders in our audience, and we could have people from around the world. Tell us about the Neuen machine and what you like about it.
Well, there's it's a single point cutter, so I guess it cuts like a lathe, but the machine is moving, not the part, if that makes any sense. Mm-hmm. So with the old style, or something that has a form tool, you're trying to cut too much material at one time. So the tool's going to chatter, and then you're going to have high and low spots. And sometimes it's minimal chatter where you can't even see it. And you can even lap the valve, and it would lap good, but it wouldn't seal. So that was the problem we were having with the old machine we were using. And I got to a point where I had to cut all the angles separately instead of using the form tool because I couldn't get what I wanted it. I couldn't get it to be the way I wanted it to be. So, but the only problem with that, when you're using separate angles, the depth equals width. So if you had to go a little deeper on one, you'd have to start all over. So on a 16 valve head, it would take like 48 plunges to do a valve job. And with this new machine, you don't even have to lap the valves. It cuts it so perfect that, I mean, I think every NASCAR team is using it, and every F1 team is probably using it. So it's the choice of, I guess, I think most people don't know about it because they're not, I don't think they can really keep up supply and demand wise.
Wow.
You know, like there's more people that want to buy the machine than they can produce them. I would think, I'm not exactly sure, but it's a desirable piece.
Yeah, that's great. Okay, I'll ask a question of Martin. Willy, Martin, Francisco, and I have dinner together every year at the Autosport show. And so it's nice to catch up with you kind of mid-year this way. And one of the things I love talking to Martin and Willy about is racing. And I'm not racing as an industry, but they go racing on the weekends and they just have a ball. And it's very infectious. And it's not the 24 hours of Le Mans, but they can't wait to get back in that race car. So Martin, tell us what you guys do.
Well, in the racing part of it, my dad and I race in a class with NASA. It's a super touring car class, so it's driven by power to weight ratio. We're actually leaving tomorrow to go race this weekend in Sonoma. So we both race against each other. I drive an S1000, he drives a BMW E36. So it's fun. We have a big class, about 20 cars or so, all the same power. We enjoy it. It's gotten us a chance to tinker with the engines, and Tom has done some cylinder heads for us. We put our product in it. We can see, differences, how, our product influences our engines. So we can see that firsthand. So we're not only, people that, make valves, but we're our own customers as well. So we use what we sell. So it's kind of enjoyable in that sense.
Yeah, it's interesting to race what you make, psychologically. So you want the best thing and you have to race it, so you want to, your car to be reliable also, so I will race it. And, we are not professional drivers, so we do mistakes, some overriding from time to time, and say, whoops, there we go. We have to make it survive.
I love talking to you guys about that. And I think so many parts manufacturers in racing, at the end of the day, they just want to win races, either on the weekend as part of their hobby, or when you make the parts, you're putting them out there and you're helping a team out there win races. And the way the development of the engine just keeps pushing the parts manufacturers to get better and solve problems. It's really remarkable to watch a company like SuperTech. And then I want to tell you, I admire your relationship as a father and son. So Martin's very respectful of Willy and really listens to Willy, especially on the technical side of things. And then Martin has the bold ideas of youth that makes Willy nervous. And I think it's just really a great combination of energies to run SuperTech. So congratulations to you both.
Thank you. We have our moments for sure. Then we have our moments, but
you have to, but you know what? That's part of the energy. That everybody's got to have that, and so it's great. And I'll just ask another question. What's the most common puzzle you get thrown at you on the tech lines at SuperTech? Like, what is there a repeated thing people call up and say, "I'm having this problem," and right now you can just tell them, "Do this," and you won't have that problem anymore.
There are always, kind of issues. I mean, in the whole, valve train package, sometimes, because it not only involves the valves, but, we involves, spring kits, how you control the valve train, So there are issues controlling the valve train sometimes, So that is, the most common question, how to control the valve train, involving valve springs, spring pressure, kind of spring pressure that they need, for certain applications. Most of the questions are around that. Of course, like you said at the beginning, also, valves are one of the most exposed valves in an engine. Anything wrong that goes in the engine, will, may take the life of the valve. You hit, override the engine, you clip the valves, and or you hit the piston, or even, assembling the engine. Some people, do things, when they assemble the engine, and sometimes things go wrong. Sometimes they don't know what happened, and sometimes they come to us, hey, this is what happened. What do you think? So you have to be doing, sometimes the job of a detective, to try to find out what happened. That, is something that happens because the exposure that a valve has in the engine.
And Tom, I'd like to ask you a question. It's really neat to see someone of your expertise with cylinder heads and valve trains working so closely with SuperTech. What does a race engine specialist like yourself, what are the kind of special benefits of working closely with a parts supplier like SuperTech, Tom?
Well, I like Willy and Martin because if I find something that I think can help improve their product, they're really willing to take that and make the change. So like we had that one thing with the seal, I felt like it was hard to be pushed on. So we started looking at it and I was like, put a little bit bigger chamfer on the second barb. And Willy was like, yeah. But what kind of blows me away is like, does anybody ever call you and say that they had a problem putting that seal on? And he's like, no. And I'm like, man, I must be like really, I don't know how to put it, but I like, how can you not? It's like something's wrong here. So, I need to, like he said, you got to dissect it and try to figure out what was the problem. And we started looking at it really close and like, it seemed if you put a bigger chamfer on the second barb, it would actually help it. So I mentioned it to him, and maybe about a month later, they all started coming with this barb, with this chamfer on it, and like the seal just slides right on now. I was like, wow, that worked. I see that thing where he's saying on the valve, a convex area. I've never seen a valve with a convex shape on the chamber side, only a dished. And if you've seen that, maybe it is for flow, but I think it would add a lot of weight. And to touch on the part where Willy was talking about valve warpage, I think a lot of the drag racers see warpage because, if you look at videos when people run down the track, when they cross the finish line, they hit all the switches and turn everything off. So if that valve is glowing red and you shut it off, there's going to be a couple of valves. There's going to be some of them that are open. They're not all going to be shut. So I think it's the ones that are open that have more tendency to warp than it would be the ones that are closed. So I tell a lot of the guys that race, just leave it running and try to let the temperature normalize a little bit before you shut it off.
Did they find good results from that? Have they been doing it?
I don't know. They don't give you much feedback, so.
They only call you when there's a problem.
Yeah, I need another one. That's drag racing. They just go through them, so to a point where it's hard. The cores are even hard to find.
Yeah. And Tom, I have another question for you. Do you recommend that racers use a cylinder head temp gauge to keep an eye on what the head might be going through? And if you don't recommend it, why is that?
I recommend EGTs. That way you can really tell what's going on. Most heads have that temperature gauge or temperature sensor right in the head. I don't know how accurate it is, but EGT gauges, I think, is what, you know, that or like what they're using now that Lambda, so they can see. But an EGT will tell you which cylinder is, how hot each cylinder is. So, and that's how I think they used to tune the carburetors back in the day, right, JC? Anyways, yeah, I would use something in, you know, maybe run an extra gauge. I don't know.
Yeah.
I don't really see people having that temp problem, because the guys that we do them for, they're a lot of them are drag racers, so they're not doing several laps.
Yeah, right. Okay, Willie, I'll ask another question here. Is there a specific valve seal you recommend?
Valve seal?
Yeah.
Well, you know, Viton on the exhaust is, you know, Viton rubber on the exhaust. You can use them also on the intake if you like, you know, but that is a high temperature, you know, rubber that works very well, you know, for the exhaust valve. That's what we supply, and it's working pretty well.
And then also, when I look at EPARTRADE, what some of the products and new products that SuperTech has on your showcase, one of them is valve springs. So we've been talking about valves, but you have valve springs in your product line as well, right? Dual springs?
Correct. Yeah, it's an important part of our, you know, business too, because, you know, it goes along with the valve. And yeah, I mean, our springs have been, you know, pretty popular. I mean, we supply a lot of applications, you know, in the sport compact market, power sport, you know, and now getting more. I mean, we try to specialize more in overhead cams, you know, of course. You know, there are now, you know, some V8 engines with overhead cams like the Coyote engine. But yeah, I mean, we have made a lot of, you know, experience, you know, with different camshafts and, you know, valve springs. And we have done a lot of testing. So we have a, you know, very wide range of valve springs applications for every engine that you have to, you know, you have a lot of options to choose depending on the kind of, you know, kind of operation you're going to, you know, do with the engine, you know, normally aspirated, street performance, you know, turbocharged, you know, aggressive cams. We have a, you know, wide range of applications. And of course, it's important to be able to select, you know, not the stiffer always is the best, you know. That's sometimes what people do, you know, put the stiffer spring in a street performance car, you know, it's not a good business.
And I really like talking to Tom about the idea of working with SuperTech and a parts supplier like yourselves to kind of just get better at valve train and everything. And why don't you talk about that as well? Like, I imagine you have race teams and race engine builders calling you up and saying, you know, have you ever thought about doing this? And what if we tried this? How does that work with SuperTech as far as working with race engine builders?
This is a question to whom? I'm sorry.
Tom.
Yeah, Tom, or Willie.
Oh.
Willie.
Oh, Willy, okay. Well, it is very important for us, you know, because not only we correct maybe some things that are not, you know, ideal, but sometimes we even change the complete design sometimes. For example, something, if you read right now, you know, this sport magazine, you will see an article about the modifications that we have done into the E46, a BMW E46 engine, in that racing market, the E46 has a lot of problems, spitting out, the shim, adjusting shim that goes on top of the retainer. So basically, we did a lot of modifications into that, valve train. We changed the springs, we adjusted the frequency of the spring, we modified the retainer, we modified the valve groove and locks. We made a new retainer, and instead of the factory shim, we use a lash cap. And there is a lot of success with that system. It's a completely different thing that we made based on the problem that customer brought to us. Hey, how can we solve this issue? That was happening repeatedly, with that engine. So we, went back to the drawing board and say, well, let's do this, all this modification, and it's working fine.
Very
So
cool.
that's the importance of working with engine builders and, or drivers sometimes that, suffer the issue,
Very cool. Okay, I'm just going to ask a question about these times, the pandemic, and just feel free to answer it however you want to. It's a weird question, but people are curious about it. What's happening out there in the racing industry from this pandemic? What are you seeing? I mean, kind of cars are still rolling, but it's just hard to gauge where the industry's at month after month, week after week. And then do you have any advice for racing businesses out there to get through this thing? So what do you see in the industry as far as this pandemic?
I think we see a lot of people have a lot of time on their hands to be able to work on their cars that perhaps didn't have it prior. So it's allowing them to actually work on their cars. So we've seen our business go up, I think, in direct relation to that. No one's really, right now, people are starting to go back to racing. But for the first couple of months of this pandemic, nobody was racing. So I think that allowed a lot of people to catch up on their projects, on their engine builds, if they wanted to do something that perhaps they were putting it out till end of the season. That was the right time to do that, as we did that ourselves in our cars. So it kind of gave a lot of people that time to be able to do that, the downtime that perhaps they didn't have or weren't going to foresee that. So that kind of, we saw a spike in our business because of that. I think because of that. Now we're seeing a lot more people going to the track and start racing. So now we're starting to see maybe the effects of that, people, having engine issues. Now we're having some customers come back and, increasing our sales as well because of that. People are just now going back to the track. So while I think the pandemic has affected a lot of people in negative ways, in a way it kind of affected us in a positive way as far as sales. We did have to have, a moment where some of our employees had to work from home. Our production was low because of that. So we were a little bit backed up on delivery of our product. But now we've got, as things are opening back up and things are moving forward, we're seeing a little bit more production being up to
people. And Tom have even come to us and said, hey, I just measured the eccentricity of the valve. Have you done that? Remember, Tom?
Yeah.
Measuring the eccentricity of the valve?
Yeah, we had that little Cosworth gauge that you can actually break it down to tenths to see how true it ran. But yeah, like the springs are critical, and I haven't seen a broken SuperTech spring.
Yeah.
When a spring breaks, that's usually one of the most feared thing for an engine builder is a spring break.
Right.
That happens.
Well, the thing is,
drop a valve.
yeah.
Bye.
The thing is, we designed the spring to work like the catalog says, But, what happens is, we have seen in the market also, many people take the spring, and say, okay, this is a spring and can work in any condition. Then they start shimming the spring, you know, using high lift cams, and then you are, you know, working in a different operating conditions from where the spring was, you know, calculated to work with. So that is an important consideration to keep in mind also, you know. When somebody comes say, you know, I want to use this spring for a different engine. Well, okay, but let me know what's the install height and what's the lift. And I will tell you if you can do that or you cannot do that, you know, because all the springs have been calculated to work in a certain way. And many people do that, you know, sometimes, you know, okay, they start shimming the spring or using that in a different engine and different setup. And that's where, you know, you may get in trouble.
Yeah. Very good. And then Tom, I just want to ask kind of an open-ended question of you in case you had something you wanted to add. You know, you look ahead to what we're doing here and talking to the racing industry about valves and race engine applications. Tom, is there anything we haven't talked about? There's a point that maybe you want to make before we close this up. Tom?
Not really, I guess.
That's fine.
I protect.
Now, when you work with a customer and you've got the valve train, the cylinder head just perfectly, and they call you up a week later saying something's wrong, and it's not because of what you did, it's something that they do, what kind of problems are your customers having because they do something boneheaded on their end?
They put it together wrong, put the cam in wrong, have the timing wrong. That's would be the first, you know, before the engine even ran. Right. Like they would bend a valve or something like that. Secondly, would just be torching it on the dyno. So that's happened a few times, I guess.
That makes me laugh. That's
that's how you learn. So
yeah.
Learn from your mistakes. Just don't do a lot of them.
Yeah, right.
Cost a lot of money.
That's good advice. Less mistakes. Pacific time, Wednesday, September 2nd. That'll be our next one. And then that'll be followed by Stand 21, safety gear, IBOC, suspension. And I don't have the others in September, but we'll have a full calendar weekly in the month of September. So I have one more question for Willy from the audience. Willy, do you use diamond-like coatings on valve stems? Or do you prefer WPC? I'm not sure what WPC is. I mean,
we do coatings in-house, but not the DLC or WPC. I mean, WPC is a proprietary treatment, and we do WPC, not only with valves, but especially with cam followers, the tappets. Mm-hmm. We do, WPC. And then we also do DLC coatings, but not in-house. So we send them to, a third party to do that DLC coating. Okay. Not very frequent that we do it. I mean, very frequent with, with tappets. Not that much with valves.
Okay. All right, well, we kind of wrap these things up within an hour so everybody can get back to work and get on with their lives. This has been great. Willy, Martin, Tom, thank you so much for taking your time and being part of this. It's difficult, challenging times for the racing industry. I think if we can be creative and move fast in different directions and do things we've never done before, I think that's the best route for us to take right now. So I love these Zoom meetings as an answer to kind of a problem that we're having, getting together personally. And then also I just want to spread the word again about Online Race Industry Week, November 30th through December 4th. Again, it's something new we've never done before, but we just haven't had this happen to us. And EPARTRADE is well set to really put on a good race industry week for the racing business. So we'll get that done. So thanks so much for being here, and we can bring this to a close.
Thank
Thanks
you.
for having us.
Thank you. Thank you.
That's great.
It was a pleasure.
Thank you.
Thank you.